Welcome you all in fluid mechanics lecture. Today topic is continuity equation. Continuity equation. This is also called conservation of mass. So all fluid flow must satisfy the conservation of mass. That is means continuity equation. So we have in a previous lecture we have derived the continuity equation, right? So continuity equation here del rho by del t plus this is the delta operator, so we can write in this form. So if we expand this delta of del operator or delta operator, del, this is a vector, we can write this is del y del x I plus del y j plus del y del j k. Here we can write this is, and this is density, and this is the velocity vector. So when we expand it, so we know first we take this term and dot product with this here. So when we do the this dot product, so what we will get? So we will get I terms is there, and and remaining this term I dot j, they become 0, and this is also become 0 because I dot j and I dot k, these are the perpendicular. So we know a dot b equals to ab cos theta. Theta is here is 90, so cos 90 is 0. So here we will get only first term. I mean, so this one, only this one remaining terms here, del v upon del v, there del v upon del y, this value, there will some value of this one, because v is a function of x, y and z, u, v and w all. U also function of x, y and g, and v also, and similarly w also, right? So here, if so, we will get this is the continuity equation in for the Cartesian coordinates, right? So this is for continuity equation of Cartesian coordinate. If flow is steady or incompressible, steady means property at a point remain constant. So if flow is incompressible also, so this will also 0, both the cases. And here we know this, if it is incompressible, so this row will comes out outside, so we can write this one, because this is rho is constant in, right? Incompressible means there is a fixed value of rho, so rho is constant, so rho is constant, right? So this constant value multiply of 2, 2 equals to 0, so this is constant, so rho cannot be 0, only possible is this term will be 0. So here del u by del x, this is 0. So this is the continuity equation for a incompressible flow field, right? So this is the continuity equation for a steady and incompressible flow field, right? So if for 2D incompressible and steady flow field, so 2D here means del, their w term is 0 only, right? Velocity. So del w upon del z. So this is 0. So here we will get this is the continuity equation for 2D, right? So where its application very important. For here example 1, there are velocity component are given. So find this is a possible case or not, means this is the possible case of fluid flow or not. So if it is possible case of fluid flow, so it must satisfy the continuity equation. So if this value be, this is for 2D, u and v is there. So for 2D incompressible fluid flow, the continuity equation is this form. So it will put this value here, u and v. So we will get, so we will get 3 minus 3 when we differentiate this u term with respect to x and v term with respect to y. So we will get 3 minus 3, which is equal to 0. So this is satisfy satisfy the continuity equation. So it is a possible case of fluid flow, right? So similarly for second case, when u equals to this is given x square y and v equals to x y square. So when we put this value in a continuity equation, so we will get this one, right? So we will get this one. So these are cancel out, and finally this is also satisfy the continuity equation. So this is also possible case of fluid flow, right? In a third case, we have velocity component u equals to this and v equals to this one. So when we put this value in continuity equation, so this is not equals to 0. So this is, this is a not a possible case of fluid flow. So means this is not possible. So continuity equation is very important, right?